Hello there, Honors Algebra students. Mr. Lawrence here, and I am homesick making this video. I'm not sure if I'm going to be able to be back Wednesday. I hope I can. But I'm making this video for in class. If we don't use it in class, then I will use it. It'll be a video at night, so you may hear me say some things. Make it sound like, hey, wait a minute, why is he talking about this? We're not in class. Well, that's why, because I'm trying to make it for both. So anyway, don't let that confuse you. Now, we're going to be talking about point slope form, which you did in class today, but we're going to quickly review what we know about the different types of graphing. For example, first type we learned was slope intercept form, the y equals mx plus b. And when we're in that form, we know that this is our y-intercept, right? And we begin by plotting our y-intercept. So if I look at this red equation, I know my b is the 0.08, right? So I'm going to go 1, 2, 3, 4, 5, 6, 7, 8. Okay. And then my slope is the m number here, right? That's my movement. And in this case, my rise and run. So my slope, my rise and my run is going to be 1/3, except one of those needs to be negative, not both. It doesn't matter if I put the negative in the numerator or denominator, but one of them must be negative. So I'm going to move this point, move from the y-intercept. I'm going to move down 1 and write 1, 2, 3. There's the second point. Now, had I made the denominator negative, I would have gone up 1 and back 1, 2, 3, and that's a good way to graph. I like to do it that way. And then I'm ready to go. I've got 3 points, so my graph can be pretty accurate. And remember, don't let me fool you, Kane, if I ask you how many points are on that line, you know the answer is not 3, right? Yeah, I'll bet you know that, buddy. Okay, so, well, actually, I guess I should keep it red. There we go. There is my graph. Now, some of you might be wondering, should I label the points? Well, it is good practice to label a couple of points. If you have good information here like this, then, I don't get too upset if you don't. But there's nothing wrong with doing this and labeling 2 of the points, okay? Now, I normally don't do this, but just in the interest of setting up this video in time, I'm going to do another equation, graph another line right on here. Because sometimes when I'm in slope-intercept form, or I'm not quite in slope-intercept form, but it's a real easy fix. Now, remember, how do I undo? I need to have this y alone, right? How do I undo the 2? Well, how is it attached? Josh, you listen to this. The 2 is attached by multiplication, so I'm going to divide. Okay, I'm going to divide, but I have to divide in all 3 places. If it had been like this, y plus 2 equals 5x minus 6, well, then I would subtract 2 from both sides, right? And I probably wouldn't write the 2 there because those aren't like terms. I'd write it here. And some of you are thinking, well, wait, you didn't do it to all 3 terms. No, I do it to both sides. And in multiplication or division, doing it to both sides is distributing. So the left-hand side becomes y. I'm going to leave 5 over 2x. I'm sure Austin can tell you the benefit of leaving an improper fraction there. And now I know my y-intercept is the point 0, negative 3, and my slope is 5 over 2. So I'm going to plot 0, negative 3. I begin with that point, and then I'm going to rise and run from there. Sorry about that. I'm going to rise 5, there's 3, 4, 5, and run 2. Or I could change both signs and 1, 2, 3, 4, 5, and back 2. And look at that, they end up on the same line. All right, so 1, 2, 3, 4, 5, 1, 2. And I get a line that looks something like that. Of course, I have to adjust it. Gotham will tell you that, it's not a line right now. Give me a second, Gotham. I'm getting there, buddy. All right. And that looks pretty decent like that. Okay, so that's slope-intercept form. Then there are some times when it's not so easy to get the y alone. We have standard form. And remember, in standard form, we learned that the y-intercept, or the b, can be found by taking C and dividing it by B. The x-intercept can be found by doing C divided by A. And of course, the slope can be found by taking the negative of A over B. So when I have an equation like 3x plus 4y equals 8, and I know that A equals 3, B equals 4, and C equals 8, I'm going to use two of those three to make my graph. Now, right off the bat, I don't think I'm going to use the x-intercept. Why do you think that is, Alex? Why don't you think I want to use the x-intercept? Well, hopefully you said 8 divided by 3 isn't an even number, or isn't a whole number, and it's a little more challenging to graph. So instead, I'll find the y-intercept, which I notice will be a whole number, because I'll take 8 divided by 4 and get 2, so my y-intercept occurs at 0, 2. And then my slope, I'll take the negative of A and put it over B. So all I have to do is plot the point 0, 2. There's my slope, or excuse me, there's my y-intercept. And I keep doing that. I'll go rise -3 and run 1, 2, 3, 4. Or I could have rose 1, 2, 3 and ran 1, 2, 3, 4 in the negative direction, and I get the same line. Sorry, it's getting hard to see. I'm probably going to need to lay down and rest a little more here. Oh, it's so much fun to be sick, isn't it? Okay. So, here we go. And I'm only doing one line on the graph, so it doesn't matter what color I choose. All right, there we go. So when I do standard form, I decide which two I'm going to use, x-intercept, y-intercept, slope. I'll use the two easiest. Okay, now, yesterday in class, you learned about point-slope form. And with point-slope form, uh, it can be easy because you can easily identify a point. The point, the coordinates of the point are hidden here and here. The only thing is you have to change the signs, right? So my point is going to be x-coordinate of -6 and a y-coordinate of 5, because that 5 is negative, right? And then my slope is sitting right here. So my slope is 2, or as a fraction, 2 over 1. So I just plot the point -6, 5, 1, 2, 3, 4, 5, 6, 2, 3, 4, 5. And then I use my slope to rise and run. Hey, look at that, I got it right. So I'm going to rise 2 and run 1. Or I could have gone down 2 and left 1 and run -1. And now I have my line, rise 2, run 1. Yeah, that looks pretty decent. It's going to be hard to get it, 100% accurate, but you should do the best you can. Make sure you're always making lines. Make sure you take up a decent amount of the graph. Okay. And there we go. Okay. Now the green one, very similar. I'm going to do my point, which will be a point 1, -8. I look there for my x-coordinate, change a sign. Look there for my y-coordinate, change a sign. My slope will be -2/3. So I plot 1, -8, which I believe is right there. I infinitely clone it. And I go down 2 and right 3. Or I could have gone up 2 and left 3. And there we go. And let's get my line on there. Back up 2, back 1, 2, 3. And this one I'll just put an arrowhead on because I think it looks fine as it is. I want to be good, but I don't want to strive too much for perfection because that can be a character flaw. Okay, Now, by the way, um, what about equations that look like this? Sometimes these give kids so much trouble. Well, let's start with the green one. I'm going to suggest to you that the green one is in slope-intercept form. Sure it is. Y equals how many x's? 0x plus 2. So my y-intercept is 0, 2. My slope is 0 over 1, right? Rise and run, which is the same as 0. See, in the beginning, why it was so important to learn. So I'll 0 over 2, and then I will, let me clone him, rise 0, run 1, rise 0, run 1, rise 0, run 1. I'll bet Erica can tell you that, well, it's going to make a horizontal line. You bet your boots it will. All right. So, and I'll make him green, even though it's not easy being green. All right, now the red one is not in any form. I guess you could argue that it's in standard form. You could say, well, it's ax plus by equals c, where in this case b would be 0. We could do it that way. Let's approach it that way. So if I think about it as 3x plus 0y equals 3. Oh, not 3x, just plain old x, sorry. X plus 0y equals 3. Okay, so that's standard form, right? Well, I'm not going to find my y-intercept because that would mean I'd have to divide by 0, and I'm never allowed to divide by 0. So I'm going to find the x-intercept, which is going to be 1 divided by 3, so 3, 0. My slope is an undefined slope, which should be a huge hint for you, but you could write the slope as negative 1 over 0. Okay, it is an undefined slope, but there is a type of line that has an undefined slope. 1, 2, 3, 0. And then I infinitely clone. Hopefully you know what type of line has an undefined slope. Let's see, I'll rise negative 1, run 0, and rise negative 1, run 0. Well, now you should see it if you didn't see it before. It is a vertical line. Yeah, a vertical line. There's another way to think about it, and I can show you. Give me 1 second here to get caught up to myself. There you go. The x equals equation proved, I can't talk, gave us a vertical line, and the y equals equation gave us a horizontal line. If we think about it in terms of tables, if you made an input-output table, well, x would always be 3. How do I know? Because y equals 3, and y could be any number you wanted. But in this situation, x could be any number you wanted, 1, 2, 3, but y would always be 3. Okay, now I prefer to think of this as standard form. Find the x-intercept, find the slope, and know it's going to be a vertical line. Have a slope with a denominator of 0, and this as slope-intercept form. Okay, with 0 x's involved, y equals 0x plus 3. All right, that's it for the video. Mr. Lawrence signing off. Have a good night, everybody.